Okay, thank you very much for joining this session. Today I will show you the kernel boot-time tracing. So I'm Masami Hiramatsu. I'm working for Linaro and Linaro members as a tech lead for learning team, and I'm a maintainer of the K-probes and related tracing features and tools. So today's talk is mainly for the let's say my maintenance work. So first, why we need the kernel boot time tracing? Um, we need to sometimes we need to debug and analyze the boot time errors and the performance issues. So that in that case we would like to measure the performance statistics of the kernel boot and or they analyze that the driver initialization failures and debug and the boot process or something like that. So um, what we have, we already have some kernel command line options for the tracing. There are, for example, there are setup options, trace options, or they output the trace point event to print K, or enable events or ftrace setting that the tracers and tracing. This filtering is for the function trace filters, K probes, or something like that. You can find these are options in a documentation, the kernel parameters text. And here is some example of the kernel command line parameters in the graph configuration file. So you can see the long uh, commands lines here, so that you can add options commands as the command line parameters. However, we have some limitations. One is actually that the size limitation. The kernel command line size is sometimes small. It actually the minimum size is 256. It depends on the architecture implementation. And also we have to write it down to the single line. So that some architecture actually support that like a 4 kilobyte thing along the kernel command line, but who want to read the 4 kilobyte string single line of options? It's very hard to read the complicated options. And only actually the current options only support the partial features of the ftrace. Because ftrace has so many features like per event filters and per event actions, and also instances. And the recently we introduced the histograms. These are very long. Needs are very long and complex settings. So it's too complex to write into the single command line. So how we can solve this issue, this limitation? Uh, We have some options. The first option is using the Initrd FS, but in a like a writing the shell script in Initrd FS, but it's too late for the kernel boot time tracing. So the second option is expanding the command kernel command line, but it's not easy to write down. As I said, it's not easy to write down the complex tracing options on the bootloader. And the next one is reusing the structured boot time data, like device trees. Actually, the device tree, because it's well documented and structured. And actually, I tried to implement the boot time tracing on the device tree in version 1 and version 2 series. However, it's not because device tree is only for the hardware description, not for the software settings. So finally, I decided to introduce new boot time data. It's an extra boot configuration. So what the extra boot configuration? It's a new kernel command line extension. Like I call it Bootconfig. It's a plain ASCII text tree structured key value list. It's like a structured syscontrol.conf. So that you can see that the example, some keywords equal values, and also we can consolidate several settings in with the braces. This one is loaded with the Initrd image when boot, and in kernel, it also provides some in-kernel APIs, special APIs for the flexible option passing. The syntax of the extra boot configuration is very simple. It's including start with the key dot word, so that dot separated words equal values, and you can add the values with a comma separated one, and add a comment. You can add a comment. So and also it can say consolidate the keywords if the parent keyword is same. For example, key dot word 1 equal value 1 and key dot word 2 equal value 2. You can write it down as a key word 1 equal value 1 and word 2 equal value 2, so that you can skip the key with the braces. And also, we have several assignments. Simple assignment, so equal, defines the value of the key. And if you use a colon equal, this one overrides the previous definition. So that you can change the previous definition. And also, plus equal means that the append value set as an array element. So that the key equal foo and the key plus equal var. This means that the key equal foo come var. So that it's become an array. And extra boot configuration is actually loaded with Initrd. So the boot config command we introduced, that will append the boot configuration file with some footer data. So that by using this command, you can update the Initrd with the boot config instead of using some changing the bootloader's settings. So, however, you also need a boot config kernel parameter, kernel command line, to enable the parsing. So, boot time tracing with the boot config is here. So, the boot time tracing options in the boot config start from ftrace dot keyword. So but also there are some existing kernel parameters which can be started with the kernel dot. I will show you the example afterwards. So with that, we can define, for example, per event and per instance settings like this. So ftrace event and group and the event name and filter, set up the per event filter And also we can make trace instances. So instances will, provide you to, what's it, ability to trace the different context, different tracers. And also you can define the K-probes events and synthetic events as as this. For details, you can check that this documentation in a kernel tree. Here is an example of the boot-time tracing. So you can see that the ftrace keyword start with the ftrace and options, set up that some options, and also set up that the buffer size and other K-probes events with filters and enable it. Of course, there are some kernel parameters options you can set by using the kernel prefix. So that the kernel TP print K means that the TP print K command line option. And another use case is to making the histograms inside the kernel. For example, this one is showing that making synthetic events inside the kernel when a boot, and it makes a histogram. What the histogram of is a init call. The init call is an initialize function call, and it will make save the timestamp of the start and the calculate the latencies in a finish event and send it to the init call latency event, so that this will make a histogram of the init call histogram, latency histogram. And another use case is here. It's actually ongoing work, but you can make a function call graph in a specific init function at boot. Yeah, with the K-probes, so that the K-probes put the one K-probe in, for example, PCI proc init function, the entry of the PCI init function, and tracing on. And also, when we return from the PCI proc init, at that point, we will disable the tracing with these actions and set up the tracers as a function graph. And trace on equals 0 means that the disable tracing by default. So only the period from this event and this event, the function graph is enabled. We also have the two helper scripts. One is ftrace to bconf, and this one is converting the ftrace current settings to the bootconfig. And also bconf to ftrace.sh. This also convert the given bootconfig file to ftrace shell script, so that you can interactively set up the ftrace and get the boot config from that by using the ftrace to bconf. And or you can check that your boot config is correctly written by using this bconf to ftrace script. So how we can start using the boot config and boot time script tracing. It's you need to build and install kernel with these configs, config boot config and also boot time tracing enabled, and build the tools boot config. and set up ftrace as you like. And I'll run this script ftrace to bconf to get the bootconfig file. Of course, you may need to customize the file and apply the configuration file to the Initrd RD image with this command, and boot the kernel with the bootconfig, so that you can get the boot time tracing result. So one note is the currently boot time tracing can trace most of the device driver initialization, so device init call. However, it starts from the end of the FS init call, so that before this, like a subsystem init call, post-core arch init call, we cannot trace it at this moment. So, okay, I will show a demo of that. So here is the examples. So what I showed, and at first we need to apply the boot config, and so that applied boot config. So this will show that this will apply this boot config file to the Initrd FS, and this one checks that, and boot the kernel with the boot config option. Then it will start the kernel with the tracing. So you can see that there are many VFS read event on the printk buffer, because we set up the printk buffer. You can check that what kind of boot config setup via proc boot config, so that you can see that this one, and also you can check that the command line. You will see that the tp-printk is added to the command line from the bootconfig. And also we have, for example, another one is like making this one is actually the second example. It's it will make a init call histogram. Okay, this kernel debug tracing, and it should make a synthetic event. Yeah, we can see that the new synthetic event, and so that are events init call, synthetic events init call latency and histogram. Oops. All right. Okay. Sorry, something makes long. No. Instances. Yeah. I will. Sorry. This one is a bit different. Okay. Yeah, we can see that the histograms with the init call. Actually, that this one is a bit different from the some example. Okay, so that in an example we don't have an instance.who, but this example, this code shows that added actually that instances. Yeah. Yeah, like this. So that if you remove this one, then you can see that the histogram on the first one, the top directory. Okay, so it's a time. So the current status. we've almost done. The actual, the basic implementation is done in a Linux 5.6. And there are some ongoing work, like a Kernel probe support and the tracing on support. The example 3 will be pushed into the 5.10. And I'm currently working on future works, like increasing the traceable code. So that starting from starting from the core init code, that will be expand the traceable code. And also enhancing the histogram syntax and bootconfig support on the bootloaders. So that's all from me. Would you have any questions? If we have questions, please make it on the chat. Okay. Device tree to pass config file to this the kernel when working on customized kernel for clients, employers. Before I give some benefits, including binary structure and existing tools to use to modify the config before the kernel starts. Something more. Okay. Yeah, so Paul, you can use that the bootconfig to add your options. Yeah. Sorry, it's a time. I'm on the chat, so that please ask me on the chat, and yeah, I will finish today's session. Thank you very much, and
Thank you,
enjoy
Masa.
your virtual connect.
Yeah. I think we still have 2 minutes. There's
have
a
2 minutes?
question on the chart.
Oh, then oh,
Yeah.
yeah. If someone has any questions, please make it on the chat.
Do you want to answer
I
it?
guess my
We
question
do
is,
have 2 minutes left, or
okay.
1.5 minutes.
I guess from Paul's, Darius, how could I have a function graph of everything that happens under the pin control driver probe during boot? Yeah, so that you can change, modify. Drew, you can modify my example number 3, so that yeah, currently this option is not available. So that I'm trying to push that these features. In that case, after that you can use that the number 3 with replacing that this what's a function name with your interesting function name. I can. Can we modify this bootconfig string from the uboot command line? Paul, currently uboot doesn't support this bootconfig, but it's actually very easy to support it because we don't need any the parser in a bootloader. Bootloader just need to add their own options after user's boot configuration and update the footer. Yeah, that will make sense for you.
Okay.
Okay.
Thank you very much, Masami.
Yeah, thank you very much.